Can you see my screen?
Yes, fine.
Thank you. I'm Sweeta. I'm from University of North Carolina at Charlotte, USA. So I will be presenting our BioASQ Task 9B Batch 5 submission. And also I will be discussing about some of our error analysis results in this presentation. These are the contributions of our submission. So as you can see, we are placed fourth in the BioASQ competition, task 9B, phase B, batch 5 submission. So we basically performed fine tuning of BioBird. After converting our data into a BioBird format, we basically did two submissions. One is by training BioBird for training 9B training data, and the other one is without training the model, just using the pre-trained weights which are available. Obviously, the model which after training the BioBird model performed well than the other submission. And as we all know that BioBird is one of the state-of-the-art performing model, but BioBird also fails in some of the, predicts some of the questions wrongly, right? So to understand where or that model fails, we perform some error analysis task on the training data, particularly on yes or no questions, and we hypothesize some of the causes of the errors, which include the presence of the modal verbs such as may. Also, we perform some statistical analysis of the WH questions and of the modal verbs. So this table gives you a summary of the results. So MDS_UNCC is our submission, and the other two are the best performing model. So if you can see, the numbers in the bold indicate that our model is equivalent or better in all these places. And for all all these places, we are placed below the best performing model. So this is one of the reason we would like to start with an yes or no error analysis first. And one more thing I would like to mention is about the list questions. We are placed 12% below the best performing model for the list question answering. So with this note, I would like to present some of our error analysis results. So as you all can see in the previous slide, we got some 78% accuracy for the yes or no questions. So to understand that further, we divided the training data into 80-20% because the goal data for the task 9B test data is not yet published. We just divided the available training data and ran the BioASQ BioBird model and had some predictions out of it. If we look into the results, out of 207 questions, 184 questions were answered correctly, and the remaining 23 questions were answered wrongly. We have gone through all these 23 questions manually and hypothesized that some of our assumptions, which are machine cannot understand the synonyms and antonyms, and also some complex question co-reference resolution is needed. These are some of our hypotheses. Apart from this, we have also noted that there is a mismatch between the training and test data in the WH question. If this is based on our statistical analysis of the question in the BioASQ data. If you look into this particular percentage, the questions which start with WH, there is only 54% of the question in the training data, but in the test data, there are 64%. Similarly, you can see some difference between the training and test data percentage of questions. So these are our findings from both the error analysis and the statistical analysis of the BioASQ data. So now coming back to our hypothesis, in the previous slide, I told you that we hypothesized few things after going through these wrong answers manually, right? So in order to check whether our hypothesis is right, what we did is we ran some experiments, and the next 2 or 3 slides will be explaining our experiment and its results. So the first hypothesis we had is co-reference resolution is needed for better understanding of the questions. So for that, we took a particular example from the BioASQ data set. If you can see this question, it talks about dronedarone and the thyroid hormone levels. And also, if you look into this snippet, the first part talks about the amiodarone and the T3 and T4 hormone levels, and the second part talks about dronedarone. So, but the question is about dronedarone. So the machine cannot answer this question correctly unless or otherwise the machine can understand that T3 and T4 specifically explains about thyroid hormone levels, because here dronedarone, the snippet gives thyroid hormone profile directly, but not T3 or T4 hormone level. So to understand whether our assumption is correct, we changed this question manually into does dronedarone alter the thyroid hormone level, and ran the BioASQ BioBert model. If we look into the results after changing the question, this particular question is predicted correctly. This is one thing. One other hypothesis we had is about modality. Better understanding of modal works is necessary. That is the hypothesis we had. So for checking whether this hypothesis is correct, we took this particular example from the BioASQ data. So if you can see, this question talks about cardiac magnetic resonance imaging. And if you look into the snippet, it talks about modern imaging. Here you can see the role may expand from the assessment of athletes. So the answer says it may. So the actual answer is no. So it is like may or may not. It is not sure that it will expand the assessment. So that is the reason we had a hypothesis that if the model can understand may is understood correctly, the model may predict it correctly. So we changed this particular question to have the word may, and ran the BioASQ model, BioASQ BioBert model. And after changing this question, this particular question is also answered correctly. So this indicates that maybe understanding modality may help us improve accuracy. But one other question which can rise here is whether modal verbs are really present in BioASQ data. So in order to look into that, we did some statistical analysis of modal verbs. If you can see, there is some significant amount of modal verbs present in all the textual part of BioASQ data, that is questions, answers, and snippets. So this gives us some scope that maybe if we concentrate on modals, if the model can understand the modal verbs, it may help us to improve the accuracy. And one other thing one other hypothesis we had is about the synonym and antonym. If you look into this particular question, it talks about BRAF mutation. So if you read this particular question and the snippet, you can understand that this talks about the effect of clinical response. And here the answer is there is a significantly reduced radioiodine uptake. So the mesh model cannot understand this particular question if it understands that effect and reduced or synonyms. To check that, we changed this question to have a word response instead of effect, and ran the BioASQ model. But still, after changing this, the model predicts this particular question wrongly. The reason why this model is performing like this is still unknown. Maybe we need to have a better understanding of that particular model, how the synonyms and antonyms are being handled to answer this question. Also, we have some accuracy results of particular type of questions. If you can see that in yes or no, there is no WH questions. Also, in list and factoid questions, you can see some 0% accuracy for some certain type of questions. So this indicates that this particular type of question is number of questions is very low, from 0 to maximum number of questions 10. So these are some of our initial error analysis results. From this error analysis results and our hypothesis, we would like to conclude that if we have a better understanding of the models like BioBot or whichever model we are running, and also if we have a better understanding of the data, we can improve our results. Also, both larger data sets for training and corpus expansion for background knowledge could lead to an improved results. Another thing we would like to conclude is deeper language understanding, that is co-reference resolution and synonym resolution, could also impact accuracy. As for the data is concerned, modalities or auxiliaries are potentially important and are present surprisingly frequently in both questions and answer. These are some conclusions we have based on our preliminary error analysis results. That is all I have. Thank you. Any questions?
Thank you very much, Seetha, for the nice and timely presentation.
Thank you.
Is there any question from the audience? Okay, so I have a question. I found very interesting the observation with the modal verbs. Do you think that a general analysis of factuality could also affect the performance? Because modal verbs is a part of the answer, but perhaps even other situations, we haven't actually done a systematic analysis in the answers of whether the snippets actually represent the factuality of what is asked by the question.
That is a good question, but at this point, maybe yes, I don't have any proof for that particular question. But I think, yes, that factuality will also be a good thing to look into, I guess.
Yes, I think it will be very interesting because apart from the verbs themselves, maybe other information in the text may indicate that the answer is negative to what it said in the text. Of course, this is more difficult, I suspect. Thank you very much, Seetha.
Thank you.
And since there are no other questions, we can proceed with the next presentation from Sultan Alrowili. Sultan here. Hi, Sultan. Thank you.
How are you doing? Good.
Nice.
So you can hear me, right?
Yes, I can hear. We can hear you.
Good.
You can also share your screen.
Okay.
Present us your work on task B as well.
You can
Thank you
see
very much.
You can see the slide, right?
Yes, we can see the slide now. You can go to full screen mode. Great. Thank you.
Okay. Hello, everyone. I hope that everyone is safe, healthy, and happy. First, let me introduce myself. My name is Sultan Alrowili, and I'm a third-year PhD student at University of Delaware under the supervision of Professor K.Vijay Shanker. Today, we'll present our work, Large Biomedical Question Answering Model with Albert and ELECTRA. This is an overview about the presentation. We'll start with motivation. Then we'll have overview about ELECTRA, then Albert. Then we will talk about our model that we introduced previously, BioM transformer, then our approach in BioASQ, result and discussion, and conclusion and future work. So let's start by talking about what motivates us to participate in this year's challenge of BioASQ. We observed that majority of the system that participated in BioASQ 8B and 7B are based on base scale. But if you look at the leaderboard in general domain, you could see like squad, glue, and super glue. You could observe that most of them are large scale. Also, there is an ongoing global fight against pandemic issues such as COVID. Soon, a couple of you probably heard about the COVID-19 challenge. So hopefully, by presenting our work and participate, we contribute to this fighting. Before I talk about ELECTRA, let's just have an overview about how the loss function, we'll not talk about the transform inside BERT, talk about the loss function inside BERT, which adapt a masking approach. It's called masking language model, or MLM. So basically you have a token of sequence, let's say 512, you mask 15% randomly of the word, then you predict with the help of FFNN, which is feed forward neural network, and softmax to get this exact word that under the mask. So ELECTRA did not add a lot in the transform architecture itself, but it brings a new solution in the loss function by coming up with two models, a small model called generator and another model called discriminator. So the generator will try to come up with, it's called a fake token. If you just observe the example here, the chef cooked the meal. So we masked the word cooked and the word da. We come up with the fake token, which is 8, that fit the context around that word. Then the role of discriminator is to judge whether this word is original or replaced. With this way, we increase the learning curve of ELECTRA compared to BERT. One of the drawbacks of BERT is the learning the pre-training is a little bit slow. So another state-of-the-art model by Google Brain team is Albert. So what Albert bring to as a new idea to transformer architecture itself by getting rid of next sentence prediction. So you have a sentence A and sentence B. You try to predict whether this sentence is the next of that sentence. So it's straightforward. So they get rid of that loose objective, and they come up with a new one called sentence order predictions, SOB. So you predict the order instead of just predicting whether that sentence comes after that sentence. Also, one of the things, a new idea they bring to the transformer itself is the factorization of the embedding matrix. There is an embedding matrix inside the transformer. If you just look at the table, you could see the number between embedding and hidden is tied. If in case of BERT large, you'll have 1000 here, and in the hidden size, you'll have 1000. In the base scale, you'll have 768, and the embedding and in the hidden the same size. So there is the number always match. So what they did, they factorize it by decreasing the embedding. Embedding here is the word embedding is tied with the vocabulary file. So by doing such idea, we can decrease the parameter. Also, another new idea, there is a couple of transformer layers inside the transform architecture. There is a redundancy between those transformer layers, so we share the parameters between them, and that could increase the performance. So this is the idea of ELECTRA and Albert. We use both idea to pre-train our model that we introduced at BioNLB 21 workshop. We pre-train ELECTRA in PubMed abstract only. We did that decision to pre-train it on PubMed abstract only, not the BMC full article, because we have a conclusion at that paper. Also, we use the vocabulary, specific domain vocabulary, which is PubMed abstract, a size of 28 and a size of 30,000. And in case of Albert. We pre-train it for 400 steps in case of ELECTRA with a batch size of 4,000 and for 200 and with a batch size of 8,000 in case of Albert. So this is probably the main contribution for our work in BioASQ, that we use our large BioM transformer model. So this is our approach in BioASQ this year challenge. So we use our model for factoid and list question. What we did, we fine-tune our pre-trained model first on squad 2.0. The difference between 1.1 and 2.0 squad is they have something called impossible question. So sometimes if you have a context and you have a question, sometimes the answer is not part of the context. So the system should retain that it's impossible. After fine-tuning in squad, we fine-tune it again on the BioASQ 9B training dataset, which given as a part of the task. If you observe, the number of questions in the squad is 130,000. And this should tell you why we are fine-tuning at the beginning on squad, to overcome the problem of limitation on the size of the BioASQ training dataset. We actually not adapt it, because BioBERT team, they did that last year, and we use a similar approach by first fine-tuning our model on MNLI, which is a text classification task, then squad, then BioASQ 9B training dataset. For yes and no question, we adapt a text classification task. So you can, because you have only a label yes or no, you could adapt the text classification task by having the context as a sentence 1, the question as a sentence 2. We use a pre-processing script developed by BioBERT team. There's a new state-of-the-art paper by Microsoft called BioBERT. I see that a couple of people who participated in BioASQ challenge, they use this state-of-the-art model. So these are the results in the batch 3 factoid question. We participated on the factoid question in batch 3 and 4. We did not participate on the list because there is a lot of pre-processing happening for the list and the yes or no question that we could not develop early. So you could see that our model, this is the top 5 system. This is the updated leaderboard score from the leaderboard. The BioASQ team, they updated the result, I think, before a couple of days. So these are the updated one. You could observe that MNLI contribute to improvement on the performance, giving us the lead on that batch. I could observe the difference between Albert and that uses squad only is like 2 to 3%. And the ELECTRA score at the last position here. If you're wondering what the IR system 2 uses, it's from Sultan University. They are using, I think, a combination of state-of-the-art model, including SpamBERT, I think BART, a new model called BERT, and other model. So another model is BioAnswer Finder by Dr. Ibrahim. I think he uses his model, BioELECTRA, that he pre-trained on PubMed abstract, but the difference here is using base scale model. Moving to the batch 4, we can see that we scored in the 2nd place, but this time with our ELECTRA, and you could observe that MNLI here did not help a lot. So that's tell you it's a fluctuation in the MNLI contribution to the performance. And Albert score at the end here, at the 5th place. And this is the last batch. So you could see that this is the top 5 system ranked by the MRR score. So ELECTRA again scored at the top without help of the MNLI. Then we have the system by Sultan University, and we have our Albert model. You could observe also one thing that we did not mention early, that we are lagging behind on the strict accuracy. So what strict accuracy means that, so as a part of your system, you generate or you come up with a top 5 candidate answer. If your answer is the exact answer as the top of your top 5 answer that your system generate, then the strict accuracy will go up. If your system show up at any position on the top 5, then the lenient accuracy will go up. You could observe that the lenient accuracy, even on the previous batches that we did not take the lead on, you could see that the lenient accuracy, we still lead on that. That's tell you if we come up with a re-ranking system that could re-rank the top 5 answer and bring the exact match on the top, we could increase the strict accuracy that's lead to better on the MRR. This would be our future work. So also we participated on the list question on the batch 5. Batch 5 actually was our last hope to win the BioASQ because we participated on the list, yes, no, and factoid. You could observe that our model, Albert, with the help of MNLI this time, we score at the top. This is the updated leaderboard. The gap is increased with the updated score. Albert also, the squad performed closely. The Fudan University also performed closely to us, and the BioBear team perform very good at this batch. I think they take the lead in the previous batch. And for yes and no question, our text classification approach give us the 3rd place here, where there is a system on the middle that have the same score and the accuracy. And ELECTRA perform at the 4th rank. So in conclusion, we could see that large scale model represented by our model score in the top in the batch 3 factoid, batch 5 factoid, and list. We score in the term of lenient accuracy on all of the batches, even the one that we did not take the lead in term of MRR, adapting text classification approach, as we show, lead us to taking the lead, sorry, the 3rd rank, which is a competitive performance. What we are planning to do in future work that we will build a simple system with our large model. We see, or we saw in the previous slide that sometime ELECTRA, in one batch, ELECTRA take the lead, Albert take the lead. What if we combine them together and have a voting system, like as an ensemble system? We also observed that the strict accuracy in our system is not that great. So by having a re-ranking system, we could improve the strict accuracy, which will lead to MLR to go up. Also, as a part of our participation in fighting the pandemic issue, we are planning to build an end-to-end biomedical question answering system. It's similar to what actually the objective of the COVID-19 challenge, if you heard about this one. And yeah, that's it for our presentation. I hope that we present our work clearly, and I thank everyone who participated in this challenge. It's proof that we work together to improve, the performance of a demanding task, which is a biomedical question answering model. Thank you, everyone.
Thank you very much, Sultan, for your presentation. Is there any question for Sultan?
Hi, I have a question.
Yeah, go ahead.
Yes, please.
Hello. So I may misunderstood, but the ELECTRA and the Albert models were both trained from scratch on PubMed.
Yes, that's I missed that part. It's pre-trained from scratch. We did not initiate the weights from general domain model. And by the way, if you change the vocabulary as we did, there is no way to pre-train it in general. And if you change the vocabulary, that means you will pre-train it from scratch. There's a couple of state-of-art methods to do that, but it's complicated. But any specific domain vocabulary mean it's pre-trained from scratch.
So in a follow-up question, so what was your setup in terms of hardware, and if the models will be released on Hugging Face, for example?
Sorry, I missed the last part.
If the models will be available.
It's a fair, by the way.
Okay.
Yeah,
and did you compare the vocabulary from your models against the PubMed word, for instance?
Yeah, actually, for the ELECTRA model, I missed that part. For the ELECTRA model, we actually using the same vocabulary as the PubMed word uses. It's the same. Exactly, it's 28. For your question about the hardware we use, we use a TPU version 3 512. So it's like racking 500 GPU of B100 Tesla. It's a massive power.
Okay, yes, thank you.
And by the way, if you check our GitHub page for the BioM transformer, we show how we reproduce our result in the BioASQ 7B challenge. You could use, I will type the link on the text chat. You could easily reproduce that on the BioASQ 9B since I noticed they released the golden dataset. So it will be straightforward to reproduce our result.
Great. This is great to have the ability to reproduce the results of the participants so that one team can build upon the results of other teams, as we have seen happening more and more in the latest years. In particular, this year, we have noticed that this happened more than the previous years.
Yeah, and just one thing, I hope that everyone in the next year use the large scale, whether it's our model or other model, because I saw a lot of brilliant system this year, but the problem they use a base scale. That's not making it fair for them. So I hope everyone would use the large scale, whether it's our model or other, so the competition would be very close.
Great, thank you, Sultan.
Thank you.
Unfortunately, we do not have more time for more questions. I can see that we already have George Palouras with us. The father of BioASQ. Welcome, George.
Hi, thank you, Tasha. Nice to be with you. And nice to see all these the people who are meeting regularly in BioASQ from around the world in different time zones this time. So, so I think we should proceed directly to the next talk, for which I'm really very proud and honored, because it's our invited talk, and it will be given by a person that I greatly respect and often ask for advice. She has great experience in the area of biomedical question answering, and not only biomedical question answering. And it's no one else but Dina Demner-Fushman. I really don't want to take any more time from her talk, which I'm sure will be very interesting. So Dina, the floor is yours.
Thank you so much. And now I'm scared because you over-advertised me. So I have to live up to the advertisement. Hopefully, at least it will be semi-interesting. And I'm sorry I missed most of the talks because it's relatively early morning here in Maryland. And I will try to share my screen and see what happens. Okay, and where's my presentation? Can you see it?
Yes, yes, it's nice.
Excellent. So as actually the previous talk gave an excellent segue into this talk, because COVID-19 was mentioned. And this is mostly what I'm going to talk about. These challenges, it's a little bit of a play on the word challenge, because it basically assumes both the challenges in actually answering questions automatically, but also the community-wide challenges that we all participate in. And I have to tell you that the views and opinions in this talk are mine and not these of the US government, and I have no financial interests. And what I'm going to talk about, of course, you know, BioASQ is one of the challenges, and you all participated in it. And obviously I'm not going and organized it, and I'm not going to talk about it because you know a lot more about it. So I'm going to listen But the three other challenges that we have participated in and organized, I'm going to give you some more details, and I'm sorry if you know all these details, so bear with me, but hopefully if you don't, then something useful will be in that talk. So when the pandemic started, I think what was really unprecedented is that the publishers realized that access to information is very important. And they came together with the government and the industry and put together that set of documents that were coming out at like, you know, breathtaking speed about the development in COVID-19. And what also started happening, people who have question answering systems, lots of my old friends started approaching me saying, can you look at our results and see if the results are any good? And of course, we all know that even if I had time to look at all the results, how do I compare these two systems? Luckily, the text retrieval conference at NIST was working on how do you compare the approaches for so many years that when the Kaggle challenge started being organized along the same lines with the COVID-19 collection, they approached NIST asking to advise them on how to actually evaluate which of these approaches are working better. And NIST in turn kind of convened the group that usually does these biomedically oriented challenges. And we came together and sort of off cycle started this TREC COVID evaluation. And I will talk a little bit about this one. And even before, as a result of the TREC COVID evaluation, we realized that, okay, we can find relevant documents, but there's thousands of those. What do you do with them? It's still not enough. So question answering is really becoming a necessity now that we have all these relevant documents coming out. And when we started talking about question answering, of course, it's not a new challenge, but what we decided to do for the first time is address different levels of expertise. So we all know that there's, you know, clinicians have questions, researchers have questions, and these are the ones that are addressed in BioASQ. But also one of my special interests is providing information to patients, to public. And we wanted to see how the same systems, or maybe we need different approaches. So that was an open question. What do we need to do for these two distinct levels of expertise? And that was the goal of the Text Analysis Conference Challenge Epidemic Question Answering. And then when we were working with sort of shout out to people who did thousands and thousands of relevance judgments in both TREC and TAC evaluations, when we talked to them about judging the answers, their main concern and discomfort was that they don't know if the answer is correct. And how do they check each answer for its correctness? So we decided that we are not going to address the correctness of the answer. So basically in the tech challenge, it is an answer or not. But luckily at about the same time in 2020, within the regular TREC cycle, the TREC misinformation track decided to focus actually on COVID questions. So that was a perfect third aspect of that, finding relevant information, how accurate that information is, and that was addressed in these misinformation challenges last year and this year. So for TREC COVID, the aspects that were new were the rapidly evolving information needs and rapidly evolving document collections. Also, the novelty was that not all of these documents were peer-reviewed. Some of these were just preprints, And what's also interesting about these preprints, they go through a review cycle and they change. So now we have in all these different collections, we have these documents that went through some kind of significant change. And we decided that we'll have at least 5 rounds of evaluation, and it did become 5 rounds. And we will be adding the topics as the information needs evolve. And the judgments will be done in the usual track manner, pulling the results of the retrieval systems. And the teams that co-organized the challenge were the National Institute of Standards, us, the Oregon Health, and AI2 and UT Health. So this is an example for those who probably in this group, everyone is familiar with what a traditional track topic looks like, but here's an example anyway. So the first part of that topic is the search terms that you would type into a search engine box. Then there is actually in our case, an actual question that was asked. And for the questions, we actually pulled our logs submitted to Medline Plus. We pulled the NIH interest groups that were asking questions at the time. Oregon Health went to their researchers and to their librarians to see what people are asking about. So these are all real life questions as they were evolving at the time of the pandemic. And then finally, the description is something that you will give to a reference librarian who's helping you to find relevant documents. And you can see that little graph that sort of confirms that, yes, the information needs were evolving. And I also have this example here that even if topically the information is the same, so the questions in the lower right are all about masks, but you can see which aspects were of importance over time. So first it was, where do I even get a mask? Then when people started getting their masks is, which one is better? And now it's because everyone has their masks and we might know which ones are better. Now we are concerned that maybe when we're indoors and exerting ourselves, maybe the masks are doing some harm. And at the top, you see the interface that was created specifically for the challenge to judge the documents as relevant or not. Oh, I froze for some reason. Okay. Oh, maybe that button will work. Oh, okay. Sorry, it was just delayed, yes. So we had, I'm skipping. We had a really good participation. As you can see here, there were overall, I think the paper has the exact numbers, but overall there was over 70 teams participating in these different rounds. There were some overlapping. Of course, the interest was kind of, picked at first and then stabilized. There's an unprecedented amount of papers that were judged as relevant, but also, the collection is specialized. So conceivably all documents are relevant to some COVID-related topic. And then Ellen Voorhees was very concerned that we have these very shallow pools and the documents are all relevant. So is the collection actually stable? And she has done lots of experiments showing that that collection is stable and it's fine to use it to evaluate your approaches. And for most purposes, this complete track COVID collection that combines all the judgments should be used. But if you have some very specialized needs for evolving topics and evolving judgments, then you can use the other subsets. They are all provided there. And the approaches that were used, you can also find all the papers describing the approaches, and something that you probably have heard about the whole morning, all the usual suspects nowadays, the BERTs and BioBERTs, and but what was really interesting, the all good systems started actually with BM25 and then did some kind of re-ranking on top of it. So that was the result of that track COVID evaluation, where we found out that yes, we can find lots and lots of relevant documents. And as the track COVID evaluation was winding down, we started working on this next step, the question answering step. And the main driving force was Travis Goodwin. He was the main organizer, and we helped as we went. And as I said, you know, not that this group needs motivation, but people need question answering. We have these experts that are saying that they don't have time to analyze the literature. They really want the answers. And of course, the answers that the doctors often go to are in these already compiled sources like Cochrane reviews and UpToDate. But in a pandemic situation, it's unlikely that you will have a Cochrane review or UpToDate. So we really need some automated methods to answer their questions. And of course, on the consumer side, they go to the internet first nowadays. And it's very important that we give them the answers. And of course, it's very important that we give them the correct answers. So we started working on this consumer health question answering some years ago. And our first question was, do reliable answers at the consumer level exist? And one of our library associates analyzed the questions that we have in our logs and had a very nice structured study that showed that about a third of the answers are in that resource that we provide for the general public, that's called Medline Plus. And then another almost over 40% is linked directly to the topics in Medline Plus. And of course, there are some topics that are some sources that are reliable but not linked. And there's 7% of the questions that could not be answered with any reliable sources. So encouraged, we know that the answers for consumers should exist. We had this consideration organizing this epidemic question answering evaluation. We should have systems that should be able to get the answers at both levels of expertise. And the questions might seem the same, but the answers should be different. And here's an example of one of the questions that I have seen in many challenges. What are the risks of COVID-19 vaccination? This is something that everyone is contemplating right now. So if you look at the left side, these are the expert level answers extracted from the recent literature. And they're talking about these very specific types of blood clotting and the factors that might be participating in that clotting and the different kinds caused by different vaccines. So that's what a clinician or a researcher will need to either treat their patients or move their research forward. For the patients, however, the CDC just says blood clots. And that's a rare complication that can occur. And they also list that specific vaccine. So, and that was why we decided to see if the systems can do that kind of analysis automatically. So this is a very involved description of the process, and then I will go over some steps in details. But basically, the idea was that we will get these questions to the question answering systems, and we are reviving these nuggets of information that were introduced in very first question answering evaluations for complex questions such as definition and event questions, where each of these factual answers is needed to build a full answer to a complex question. So traditionally, it works the way that the system answers are pulled together, same as the documents in retrieval evaluations, and then the assessors look at the answers, look at the document collection using some search engine, and come up with the answer key that contains these facts that need to be in the answer for the answer to be complete. And then they go back to the documents, and then they assign these nuggets to, and however many nuggets are in that snippet that they are considering as an answer, they assign it back and they label the answer with the nuggets that it covers. So, and the idea is that this gives you some structure, because otherwise you will either, you know, have to say this is an answer or this is not an answer, or maybe this is a partial answer. But if you have these semantic content units, then you can sort of judge what the answer actually provides. So that was the idea that when NIST introduced the nuggets first. Back then, they had that notion that some nuggets are more important than the others. So those were called the vital and OK nuggets. And the idea also was that they can only be assigned manually by the assessors because of the semantic complexity. So we tried to do it automatically. We sort of showed that, yeah, you can do it automatically and it correlates with human judgments. We also looked at these vital versus OK, and it turned out that these are very unstable and very subjective. So if you have two assessors, it's more stable. We did not have the luxury of two assessors per every answer. So we decided that we will not make the distinctions between the vital and OK. And reiterate, the task is, here's a set of questions. Mostly actually on the surface, the questions look identical, and then return a ranked list of answers at the expert level or at the consumer level. And this is what the systems have returned. And we can see that the systems have actually returned different snippets for the same question: what is the origin of COVID-19? And then this is what the assessors worked with to produce the answers, the answer keys. The systems that contributed, you can see here that we had some systems that were participating stably in all of the both rounds that I will describe in a second. And some systems participated either in a preliminary round or only in the last round. So these were the systems that contributed their answers for the assessors. And then the assessors created their answer keys and then went back and annotated these answer keys in the nuggets in each answer. So you can see in blue, the expert answers and the consumer answers are highlighted in their snippets. And this is the difference between for that same question, what the assessors thought would be an appropriate detail level for the expert and for the public. So you can see that, and in most cases, for most of the questions, the assessors assigned a lot more nuggets to the professional level. And you can see that these are very details in terms of sort of biological details, whereas on the consumer level, they are more general and give sort of a bigger picture of what is happening. AI2 was very nice in redesigning the interface to evaluate the question answering challenge right on the tail of the Track COVID challenge. And this was the interface that the assessors used. So they used basically just text documents to create their answer keys. And once the answer keys were created, they were submitted back to AI2, and then the interface was updated to give an opportunity to assign as many nuggets to the answer as possible. Then how do you actually evaluate these nuggets and these answers? How do you compare the systems? So Travis came up with this metric that he based on the NDCG. And the idea is that the systems will be rewarded for bringing the different nuggets up front. And there are different penalties. So there's 3 flavors of the metric, and the penalties for not presenting a new nugget are different in these 3 flavors. You know, in the first one, that is the strictest, you have to present only new nuggets in every answer that is ranked at the top, and then it relaxes. So the preliminary round, we viewed it as, you know, honestly producing training data for the main evaluation. And we recycled one of the, I believe it's the 5th round COVID-19 collection. We also added the documents that we have in our consumer health question answering system that we crawl from the NIH websites and CDC. We also added the World Health Organization data to the mix. We again recycled the track COVID topics. And because the relevance judgments were already available for these 45 topics, we told the systems that they can actually use just the relevant documents if they want to, of course, warning them that for the main round, there will be no judged documents. So the approaches, you have probably, even like the little snippets that I heard this morning, there is nothing new for you here in these slides. This is sort of the state of the art that was used by the systems to return the answers. And we could see that, yes, additional training data was helpful. And what was really interesting, that having prejudged documents was not helpful. So when people were building their systems from end to end, if they have some decent retrieval mechanism for finding the initial candidate documents or candidate snippets for the task, you don't actually need to know if the document is relevant or not upfront. But now we have the training data. So, and we updated the collections. So it's a brand new collection. It's more of consumer-friendly language documents, 30 brand new questions with the descriptions both for what the expert would be looking for and what a layperson will be looking for. And also no document relevance judgments, and the fully judged collection that was produced in the preliminary round could be used for training. And you see here that the results in the primary round were approximately or even better than the ones in the preliminary round, because we had training data now. We see that these 2 systems, the University of Texas and University of Waterloo and IBM have really good results. We also see that our baseline that we provided was a true baseline. It's, you know, we just used BART to generate answers to the questions, and then we mapped the answers back to the questions. So that was the absolute baseline. Turned out, yes, it was a baseline that was very easy to beat. And then we see that for the consumer level questions, the ranks swapped a little. Now University of Waterloo has the best results, and University of Texas results are now in the second place. So if we look at what was done by these two teams, it might explain the difference. So University of Texas, and I think it's fair, if you know that the evaluation metric is after the new nuggets, let's build a system that finds new nuggets. And that's exactly what Max did. He used very interesting, sophisticated approaches to find sentences, to re-rank the sentences, generate the questions from these sentences, then sort of figure out which nuggets will be in these sentences by clustering these sentences using entailment, and then re-ranking so that the new nuggets are appearing closer to the top. And that might explain, because we have seen that there's lots more nuggets in the professional answer keys. So finding all these new nuggets and presenting them upfront might have been why that system performed so successfully on the professional task. The University of Waterloo actually took a totally different approach. They have their system that they built for track COVID, and they did very minimal changes. So it's almost zero shot attempt to use a good system on a new task. So, and you can see that their system is also very sophisticated. They do retrieval, they do two types of re-ranking. And what they did, the new part, the addition for this specific task, again, to find these new nuggets was MMR, so that the only part that they actually trained on the preliminary round data was that MMR part, the weights for promoting the sentences. And again, we can see that it was a really successful approach. So the observations we have after track COVID is that I'm okay on time. I just checked if I'm running over. There are substantial differences between the answers selected for the experts and the consumers, and the level of granularity that is reflected in the nuggets. And the task is challenging, obviously, but we have some very promising results, even with like near zero shot systems. So we should probably continue exploring that. And I would really want to acknowledge, so for that task, only the NLM index section was providing all the judgments, and we are very thankful to them. So switching to the third aspect of that, finding relevant information, do we really care that it has to be reliable? Do people have enough common sense to understand if it's not? I think that CDC survey shows that people do not. And this was done in May of 2020, when, if you remember, at least in the United States, people started believing that bleach will save them from COVID. And they not only applied it to their skin, but they also took it internally. And in that survey that CDC conducted around that time, you can see that the majority of people really did not understand how harmful it would be to use bleach in other ways than it is designed for. So yes, we definitely need to have filters that do not let people get misinformation. And this is, as I mentioned, the track health misinformation track was targeting specifically that. They had these two tasks in 2020, the total recall, where you had to find all the information for a specific topic, and also the ad hoc, where you had to promote the trustworthy information. And we participated with the usual metrics. We were sort of in the middle of the pack. The one conclusion that we had, and that was Murad Saruri, who was a postdoc in the lab at the time, that we do not have enough training data for the task. So he set out to produce a new fact-checking collection. And it was just accepted for findings of EMNLP. So congratulations to Murad. And what he is providing is manually annotated evidence claim pairs. And he had sort of two issues with the existing collections. One, that the claims are generated from the sentences that will be then judged for these claims. What he wanted to do is to find real world claims and compare them to the artificial claims. And also the idea was that, well, if you find another document in the sort of consumer-oriented collection, you might not know how trustworthy that other document is. So why don't we try to find evidence that supports or refutes the claims that come sort of from the wild in these scientific articles? So then we also decided, that was Yasin Rabet's contribution, to evaluate the claim complexity. Like our claim is that these claims are more complex than the artificial claims. Is that true? We need to check that. We established some baselines for classifying the evidence as supporting, refuting, or neutral with respect to the claim. And we conclude that we created a very challenging test bed for the task. So the steps in creating the collection are to submit the track COVID, track misinformation track, and other questions that we see occurring naturally as searches to Bing, and then take the snippets that Bing returns as claims. Then use these claims to find PubMed abstracts. And it was, of course, if you just find PubMed abstracts without re-ranking, many claims were, many evidence sentences were just neutral. So we were not getting anywhere. So we kind of had to re-rank the results to get the variety of the claims. And then the assessors were instructed to extract up to 4 sentences from each abstract and label each sentence as supporting, refuting, neutral with respect to the claim. Our claim about the claim complexity was true. We can see the other data sets that we were using in our evaluations. And we can see that these new data set claims are somewhat more complex. Here's an example that comes from the collection. Ferrets can catch the coronavirus and might give it to other ferrets. So these are 2 facts. Ferrets can have it and ferrets can infect ferrets. But poultry and pigs don't appear to be at risk. So another sort of 2 claims: poultry not at risk, pigs not at risk, also some hedging, some uncertainty. So given that whole claim and finding a sentence, for example, that pig has COVID, is the claim refuting the sentence or not? Because there's hedging about pigs and there is, maybe they meant that ferrets cannot infect pigs. So you can see how it is, again, a very subjective task assigning these labels, and the assessors were instructed to go with your first reaction and label it according to their first reaction without doing too much analysis. And then to automatically determine the complexity of the claim, Yassin came up with this averaging of 3 different types of relations that can be extracted from the sentences. So the baselines that Murad evaluated were T5, bird, sidebird, and biobird, and T5 outperformed the other baselines. Also, training on one collection and comparing to the results on all the other collections, we found that in zero-shot performance, the new collection will give you better results if you train on the new collection. And of course, no news here, training on in-domain data is better than training on some other domain data. So to summarize what we learned about the challenges, specifically with finding information during pandemics, we do need question answering systems. Near zero-shot system show good promise in answering pandemic questions. And we see the differences in both the systems and approaches needed to address different levels of expertise. And again, determining if the answer is reliable is still a very challenging task. And some sort of thoughts for the future: individual and challenge research directions. We are still not done exploring different stakeholder groups. We just started scratching that surface. We did not look whether what we learned for COVID-19 applies to other emergency situations, other pandemics. We also just look for now without taking into account the time and the context of when the claim was stated and when the evidence was found. So something that was, stated, for example, before Johnson & Johnson vaccine was given to millions of people, we did not know that it can have that rare complication. So a statement that, this vaccine is complication-free would have been true before we learned about the facts. So some research direction there. We are still undecided on these nuggets. It was very hard to explain to the assessors what a nugget is and what the answer key should look like. Do they actually add value? Is that value? Are there any trade-offs there? And we still don't know how much data we need for these fine-tuning for few-shot performance that we have seen with the University of Waterloo. And of course, the evaluation metrics are a perennial item of interest. So that's it. And thank you so much for inviting me and for listening to me. And I hope you have questions.
Thank you, Dina. Thank you. It was really interesting. So I'm glad I predicted it correctly. It was an easy prediction, to be honest. And I'm really glad that you don't hesitate taking on difficult challenges having to do with consumer question answering and subjective annotation and all those difficulties that you had to deal with. Let's move to questions. We do have, I believe, about 15 minutes for questions, if I'm not mistaken. Tassos, am I correct?
Yes, we have time, 15 minutes exactly.
Great.
Or we can have an early break, right?
Well, that's an option as well, but I'm sure there will be questions. So you can raise your hand or you can write in the chat. Both will work. Dina, can you see the chat directly?
It would be nice to actually, so I'm kind of blind.
Okay, I can repeat the questions. So the one question from Salvador Lima is, how long did the annotation process take, more or less? And did you have many annotators involved?
I assume that's for the misinformation.
It doesn't say, but
Well, I can talk about, so, you know, the Trek COVID was on a very, very tight schedule. 5 weeks, 5 weeks, 5 weeks, and the assessors had just 2 weeks. And there were, I think Kirk probably has the numbers in the paper, and the workloads were somewhat different for different annotators, but I believe there's like, overall, we had probably 40 annotators. And for the library, for the index section, they were allowed to spend 10 hours a week. And we had 15 people doing that. So that's already a lot. Then for, again, the index section did all of the question answering annotations, and that took a lot longer. They were very much complaining about the complexity of producing the nuggets. So that took a really long time. For misinformation, the annotators were us, the authors on the paper, and it did take lots and lots of my nights, yes. So it's not an easy task.
okay. So I think you covered both. There was a clarification that the question was about the question answering part, but
Yeah.
I think you covered that. There is another question about the availability of the annotation interface. So is it available? The question says whether there's a live demo of it.
You know, I honestly don't know, but we can easily verify with Kyle Lowe. So it is hosted at AI2. And I know the code was in GitHub, and I don't know if it's easy to find there, but Kyle will probably be very happy to both point people to where the code resides and if the interface is available, provided.
Okay, so I guess, Tasha, can you put the email of Kyle Lowe in the chat, please, so that people can contact Kyle?
Sure, I will.
Thank you. There's another question from Martin. Could the question answering and also the misinformation task be adapted to multilingual settings, and the annotation tool be adapted to other languages?
I firmly believe that the answers are yes and yes. Then you also will, and I think that will bring us back to cross-lingual stuff, because most of the answers are probably in English. And there are probably lots of answers in some other languages, but not to the extent that you can run a challenge in each specific language. So I don't see any really, other than having people capable of understanding answers and questions in other languages, the interface itself should be very easily adaptable. The challenge, of course, yeah, there's nothing English specific to it. It's just the document collections, the pre-trained models, the additional sets that people used for to get better results. I do believe that English still is although there is a lot of work on multilingual encoders, but the resources, probably English still outweighs other languages.
If I can comment to that and add to that, I agree that the resources are scarce in other languages, but at least if you are looking at consumer content and answers, then data availability, which is probably not such a big problem as in scientific literature, where again, English is dominant, if I can say.
Yeah, and it's an excellent point. The other point that we have to consider when we go to consumers is the cultural differences. So something cross-lingual that should work for scientific literature might not be that suitable for conveying information, because talking to patients, it's not just the language, it's also how you talk to the patient in different cultures. So that we also need to take that into account.
Okay. I can't see any. There's a question from Antonio Miranda. Are you planning to explore multimodal question answering? In which clinical QA applications do you think merging medical image and text could help most?
Yes, so of course, there is the visual question answering challenge that's been running with ImageClay. I do believe they already had the session. So there, the focus is on radiology images. And again, we have several collections, I think all of them in English, unfortunately. But yeah, there is a lot of work on question answering for radiology images. And Deepak, who is going to present his and Murad's work on BioASQ a little later, started working on video question answering. So we are considering questions that will be better answered by demonstration. And so the question can be asked verbally, and then the system should return a video snippet to answer the question. I hope that answers the.
I hope so too. There's someone informs us that the VQA Med 2021 session at ImageClay was yesterday.
Right. Yeah, that's kind of what I thought.
But all the resources are online.
Yeah, and this is an ongoing challenge for several years now, so it's not that new anymore.
Okay. Are there any other questions? I don't see any hands being raised, so there is a question from Martin. Are you aware of the use of text simplification approaches used for QA, layman person, consumer questions, and answers in more technical scientific literature comment?
Yes, funny you should ask. We just started working on it, and we are working again, unfortunately, sorry, English. I could do it in Russian, but I'm not sure people will use it as much. But yeah, we started working on that topic, and it's very challenging. I think probably it's the most challenging yet.
Can you say, I don't know this word, can you tell us a bit more about it?
About what?
About this work that you have just started.
Oh yeah, so we started looking at, this is an excellent question that we've seen a lot when we tried to find the answers. Even when we annotated our questions, we had a flag that was saying research, because very often, and this is particularly true for people with some chronic incurable conditions, they are experts. They know everything that's available. So they usually come with a question, you know, like what new research is there, what new possibilities might be there. And of course, one way to search for it is in clinical trials. And many of you probably know that there is this challenge that Kirk Roberts is running within the regular track cycle, where you need to match patient to the trial, sort of find a trial for the patient. but also sometimes they just want information, and that information is only available in the scientific literature. But when you get the answer from the scientific literature, you can't really understand it without solid background in this specific research area. So we started looking at, can we simplify, and what will be a good approach to simplification? Because, you know, there is an excellent overview article that shows all the approaches that were tried for simplification. It could be summarizing into the patient language, translating into the patient language. So we just really started thinking about it and started preparing a collection for it. There are no collections to judge, even if you have a system, there are no collections to judge what the results are, if the results are any good.
That's very interesting. Perhaps I can use the last 3 minutes to ask also my questions. I have a lot. I'm not going to ask all of them. One thing that intrigued me particularly was the assessment of the consumer type questions. How do you assess this? I mean, do they have to be assessed really by people who are truly consumers or patients, or can somebody else play that role, or how do you do that?
So we had very ambitious plans, because that was exactly Kyle's concern when we were discussing how to set up the evaluation. And his concern was that basically it's sort of twofold, right? So the specialist should say, this is the answer. So, you know, the index section librarians, they are not lay people, because they all have, you know, masters and PhDs in all kinds of biology related sciences. So they are hardly lay public. And Kyle wanted us to then, after we said, okay, this is an answer, give it to someone who is really, say, at high school level of education, or close to high school, and ask them if they understand it, and to sort of paraphrase it so that we can check that they understand it. And we never got to that part. We just sort of ran out of time and, I guess, steam.
Yeah,
but you know, the answers are there, right? So we could conceivably do it offline. If someone wants to take these answers and do that experiment, that will be an excellent experiment.
Yeah, and I guess it is difficult even to try to do that, because the variability between the people who will get this answer and judge it is much bigger than the variability of scientists and researchers. I mean, you get the consumers that are in all different levels of education and different backgrounds. And
right, and there's lots of work on, you know, so Medline Plus is targeting 8 years of school. So they want the language in their topics to be no harder than 8 years of school education. But there's also lots of work on showing that literacy and health literacy are totally different things and not very much comparable. So even if someone has a PhD in physics, they can be completely health illiterate.
that's true. And this comes back to the specialized audience that you talked about earlier, people with rare diseases. They may not be very highly educated, but I'm sure they know everything about their disease.
Exactly.
I've lived that firsthand, so I can confirm that. And then again, there is also the question of how many annotators would you need per question to make sure that this is sufficiently
stable
for consumers.
So luckily, way back when, Jimmy and I got the answer to that question. 2 is enough.
Even for a layman answer.
Yeah, yeah.
Okay, that's good. Good to know that. I think we're running out of time, and I don't want to take time of the break. I would like to thank you a lot again, Dina, for being here. I'm sure we'll have you again later in the panel. Thank you for that as well. And thanks for all to all the people for the interesting questions. Let's have a break.
Thank you all so much, and thanks for the really interesting discussion. Thanks for your questions, and thanks for inviting me. And see you in half an hour, right?
See you in half an hour. Yeah. Bye-bye.
Bye. Thank you.
Bye. Thank you.